In this video, we'll examine current in parallel circuits. Before we go to parallel, let's look back at series circuits for a minute. Now, a series circuit has one pathway, right? Only one way for current to flow. One pathway. So, there's the same current everywhere. It's only one path. So, it'll have the same current. 1 amp here, 1 amp there, 1 amp there. It doesn't change throughout the current. Throughout the circuit. Now, let's go to parallel. Parallel circuits have multiple pathways. Here we have two, the inside one and that outside one. I like to call these vertical lengths legs, and I will call that leg 1 and leg 2. Now notice here, this pathway here, the leg 1 part of it, has only 1.5 amps, whereas the one next door, that leg has 3. And of course, these add to the outside. We have 3 different currents depending where you are in the circuit, don't you? So pathways can have different currents, unlike series, where it's all the same throughout. Now the reason for this is that parallel circuits have current splits and current joins. So say we have 4.5 amps here coming up around here. At this point right here, that current has to split, doesn't it? Some will go down that leg, some will go down that leg. And that's the first reason why current differs. In this situation, 1.5 came down here, and 3 came over here. So we have a difference in current between those two legs because of that split. Now, we also have joins, of course. That 1.5 comes down, and that 3 comes around the horn here and joins back to 4.5, doesn't it? Note that because of splits and joins, current can differ between pathways. It's mainly because of the splits, right? Right. So it definitely can differ throughout a parallel circuit. Okay, here's the problem I want to look at here. Let's say that you're asked to calculate the current in the 4 ammeters in this circuit. Now, 2 and 3, they're inside. They're on legs, aren't they? And the 1 and 4 are on the outside. This current here is going to split, isn't it? And this is going to be a join back to here. So I think you can probably see, if we can find these two here, if you can find the currents in ammeters 2 and 3, you can find the currents in ammeters 2 and 4 because of addition, because of the splits and joins. Alright, so how can we find the current in here, in that leg, and in that leg? Well, you're going to need to do an I equals VR calculation, I being current, for each leg. So you're going to need V and R, aren't you, for each leg? Well, I've given you the resistances, haven't I? You've got R for each of these legs. You have R, but you don't have V, do you? There's no V on here anywhere, is there? What are we going to do? Well, that tool we use in class will help us see. And there are a couple of interesting facts here that allow us to get our V. Notice we have a 9-volt battery here. The voltage is 9 to begin with, and of course at the end it comes back to 0, doesn't it? The voltage drop over the circuit is 9. 9 and 0 when you come back. Notice what happens with a parallel circuit. The 9 continues until the top of that leg, doesn't it? How about over here? It's the same 9. Isn't that interesting? That's going to help you, because the bottom down here has to be 0, getting back to here to 0. So you'll find then that the voltage drop, which is the voltage for each leg, is the same, 9 to 0. The top minus the bottom, 9 to 0. The voltage for each leg is 9 volts. This minus this, and this is always equal to the battery, and that's always 0. You've got your voltage, don't you? There you go. Now, we can do I equals VR calculations now for each leg, can't we? Leg 1, I equals 9 divided by the 4 resistance is 2.25. Leg 2, its V over R is still 9, the same, isn't it? But here the resistance is 2, so it's 4.5. We have more current here. So there you go. We have 2.25 amps here and 4.5 amps there. Now, don't these two add up to join to here to get 6.75? They do. This and that join, 6.75. Up here, we have 6.75 that splits into 2.25 and 4.5. So we can get these last two, the outsides, by using your splits and joins. But the key thing to this, I haven't got much time here, I've got like 20 seconds. Can I restate this? The key is that the voltage comes from here, 9 to 0. You'll have your R, if I give it to you anyway, and then you can calculate your current using simple V equals IR calculations for each leg, and then finding the other currents in your other ammeters, and bye.